name is Stepan. I'm an architect and partner at SA Lab, which is short for Smart Architecture Laboratory. We are based in St. Petersburg, Russia, and we are working with projects of different scales, from small pavilions to some large-scale structure and even virtual pavilions. But mostly we focus on adaptive architecture. And when I say adaptive, I mean architecture that is able to change over time. And when you are trying to design something like this, you either go modular way and design structures composed of different modules and assemble them, or you go technical way and design structures with multiple sensors, computers, and during this workshop, if you want to learn more about our practice, you can just find us on Instagram, for example, to look through our reports and learn us. For this workshop, we were focusing on creating modular structures and creating web applications to design these modular structures, trying to bring some game-like experience in designing real-life structures to make the design process more accessible to different people and more intuitive and interactive. And we were designing apps that would work on various platforms, on various devices, and various operation systems. And to achieve this goal, we use WebGL technology to create our apps working in browsers. And for participants of the workshop to be able to create their own apps, they had to, well, dive deep into web development, to learn HTML, hypertext markup language, CSS, Cascade, style sheets, JavaScript to make their apps interactive and program them, to learn 3GS library, and we were working within glitch.com platform. So this is how the environment of our workshop looked like. We were coding and designing our apps here. We had 2 days, and we worked each day for 4 hours, and participants were given a demo app. This is an example of a demo app. And you can basically add different parts, rotate them, and assemble different structures within this app. And they were able to update this app to change whatever they want, to add some functions, add some buttons, add whatever they need, change the design, and so on and so on. If you want, you can go via this link to get and try it yourself, or just scan the code to get the. It's available online, and all the apps were produced by participants are available online and are fully functioning on various devices. So participants had to produce some 3D parts for their and them into the application and then design some structures made of them. And they were concentrating on the structures of different scales, pavilions or real-life buildings, or some of them tried to create some furniture structures to maybe to create some public spaces, as something in public space, for example. This is a housing platform to generate a house, to create a house that you'd like from this part. This one is a pavilion-like structure to be located somewhere in the street, about 3 meters wide, 3 meters high. And well, this one is very unusual. And we're begin. This is an app to design space. This basically is a modular furniture system to create spaces and organize everything. And we even have an app with some parameters kind of design available in it. And basically, this is the video showing the process of how the app is functioning and how you can create and generate structures within it. So that's it. I guess I'd like to say thank you all organizers for letting me be part of this conference and for letting me to take part in this fantastic event. And I would also like to say thank you to all the participants of the workshop. They had intense 2 days, and I know that it was kind of hard to go through all this information and the knowledge needed to generate your own app working on mobiles, on laptops, and on desktop PCs. Thank you.
Yeah, thank you for this presentation. Next one will be the animated urban perception workshop, and I will give Julia Pellegrini the screen sharing or the presenter role. Okay. Perfect. Here you go. Julia, can you hear me or us?
Okay. Sorry.
No.
Here we are. Okay. Yesterday we have done this workshop about animated ways to do message of perception about cities. In the morning we have had some guests and part of the conference in order to give suggestions to our attendees and participants. The first part was about the regenerative cities with some example of GIF and collages of digital representation in order to have an immediate figurability of the city. And after the professor of the University of Valladolid about the regenerative city, we have also listened to the lessons by Alessandro Melis. Alessandro Melis is an architect and professor, director of Cluster for Sustainable Cities of the University of Portsmouth, and for the next year is also the curator of the Italian Pavilion at the Venice Architecture Biennale. He has spoken about the dark city, the connection between images, city drawings, and the biological structure as far as this pandemic period is concerned. And we can see some drawing, also digital, by Alessandro Melis. Then I presented a worldwide image as a cultural document about figurability, perception, city, drawing, images, movement, and communication. And we have spoken about the perception of the city during the pandemic period, and especially about the void of the city and the contemporary special tragic period that the city in the world were living, and unfortunately we are still living. And I have also spoken about the analog city by Aldo Rossi with the meaning of this drawing. What we have done, and this is a collage created by me, therefore the global city during the period of city, with different messages that we have communicated to our participants. We have our intentions was to give suggestions, reflections, messages, very brief, but also very meaningful. And so we have also illustrated which are the visual fields and the perceptual forces in compositions of the image, as both for GIF, animated, both for collages or other kind of drawing. As far as this specific theme is concerned, we have spoken and explained the cognitive functions and brains, connected also to the perception, the different point of view, perceptual speaking about cities, and we have introduced different points in the city in order to give a message about the city. Also with some example of drawing, on illusory drawing, linked to the philosophy of Gestalt, and also linked to cognitive function and brain. These are some image and drawings of our students of the University of Genoa at the Department of Architecture and Design about the study of symmetry and asymmetry. And we have also some animated gift about the message of city movement and the perception of the proportion of human being and the movement in the city. These examples are connected to the part explained by Michela Scaglione. I asked Martin if Michela Scaglione can speak now.
Maybe see if he's on the list. Is he there? Okay. Yes. I can.
Thank you. Then I closed the presentation, but this part was
okay.
By Michela.
But please think about a bit on the time as yeah.
So do I the presentation? Finish I?
Yeah.
Okay. Michela Scaglione spoke about the perception. No, do I have finished?
Okay. You want to? Sorry, I didn't for the math. Wasn't
because I wanted.
Okay, then I give you the. Sorry. Then okay, perfect. Then let me give you the presentation things back and hurry a bit.
Excuse me. Okay. Here we are. And Michela explained, my colleague, professor of Genoa, of the University of Genoa, explained Berlino and Genoa comparing city with the principal path in Genoa and Berlino, the principal node, and also the landmark of the two cities compared one each other. Also with the presentation of different type of city, the city of relationship or the relationship. This is also the continuous city college for London. And this is the result of one of the participants of this workshop. This is the place of Tel Aviv, and it's an empty square because of COVID victim. And this is another result of our workshop with the college by Irem Metin, a participant by the university, a student by the University of Istanbul. Instead, for this GIF, the participant is Sofer Adas, a researcher of Israel. And then we have another college with the comparison with Berlin and Genoa. And we can close this brief presentation of our result with this animated GIF about Berlin and Genoa compared together with the landmark of the two cities. Thank you very much.
Thank you.
Thank you too.
Okay. So I didn't understand it correct. So is there now Michela Scaglione talking or not? So it was a misunderstanding on my side. Okay. So okay. I don't know. The next workshop we like to present, or we want to go on, will be Building Instincts of Professor Raimund Müller. And I'll give you the presenter role. Here we go.
Thank you. I'm not professor, unfortunately, but I'm an assistant professor here at EAC Barcelona, and I will share with you my screen. Second. Yes. Can you see it all right? Okay. Okay. So I'm not going to explain actually the title of the workshop. I think it will become clear as we go along. What you see in the background is basically the long-term goal is what we can maybe call autonomous building. Here is like the rendering of small agents working together somewhere in an inaccessible site, autonomously assembling, in this case, a bridge. If you want to teach robots how to do that, we cannot really train them in reality, just throw them there, but we can train them in simulation. So the topic of this workshop is very strongly related to simulation. Conventionally, when we tell machines what to do, we give them lists of instructions, and this is one example from the University of Technology in Vienna that I was involved in some years ago. Where we were doing all the path planning for building these sculptures with the 6-axis robot, and it was like a lot of work just to generate the instructions for the machine, that then get kind of rigidly reproduced. If they don't, then it's a problem when there's a mistake or an error. That's the conventional way, and it's fairly old, so we're kind of still slightly, we find these industrial robots quite fancy in the realm of architecture. They're from the 1960s, the automotive industry, and the idea of generating instructions like that is even a lot older. So here on the left, you see a device that was conceptualized by Leon Battista Alberti to reproduce an infinite number of times without loss of quality, a map of Rome that he had spent a lot of time measuring. So he was so worried about this not being accurately drawn that he conceived this machine and also a notation for instructions of how to use it and to reproduce this plan. So that's the classical way. Obviously, in nature and with artifacts, if we can call it that, like this one, it's working in a different way because if you consider the building site on the left, if you like, and the one on the right, they're completely different, but the same instructions or the same behavioral rules on the level of the individual then collectively brings about like a result like that. So they are these kinds of and when we talk about emergent self-organization and all these fancy terms, but basically systems like that, collective, distributed systems, they have some nice properties of being flexible, like we see here, managing to do what they can do in different conditions. They're robust. If you kill 10 bees, the whole swarm is not going to fall apart, and they're also scalable. So if you add a few more, maybe it will work faster, but it's not going to dramatically change anything. Now, for artificial systems, there's a whole field of research that is looking at how to evolve at different levels behaviors, but also bodies of robots or for example, gates for walking robots, or even like maybe from the Carl Sims classic example where he evolved these virtual creatures that then had to move through virtual spaces. And we can also evolve parameters of neural controllers, just as any other list of parameters that we can evolve using genetic algorithms in this case. So these are the parameters. It's the topology of the network. It's the weights between neurons, and then there's like a bias value for each neuron, and then the activation function, which actually we don't take into account because it's uniform across the network. To do this, we prepared a while ago like this kind of software framework, which allows us to use a commercially available robotic simulator. It used to be called VRAT, now it's called KUKA CRC, to become an evaluator for a genetic algorithm. So you have a neural network controlling what the robots do in the simulation, and after some time, the genetic code that defines the neural network, it gets evaluated, it gets a fitness value. These fitness values, I don't know if you can see my mouse, but they get reported to another piece of software who then generates a next population, and so on and so forth. Here's a more pragmatic representation of this software framework. Thanks, Matt Gordon, who was also teaching in this workshop. And then what happens is, how am I time-wise, Martin? Okay, I cannot hear you, but I can see from I can read from your face that I should hurry up. Okay. So basically, what this looks like and what's following are like 4 examples that we actually did during the workshop. We had to use the cooking show principle of preparing a lot of stuff. Otherwise, in 2 days, this would have been impossible. But here you have like a bunch of robots that without any control, they just do random stuff because it's a physically accurate simulation. They bump into each other, there is friction, there is gravity, and so on. And after a few generations of training, we obtain a controller, and in this case, the fitness function was designed in such a way that the robots understand how to balance, how to not fall on their face, using their 2 independently controlled motors. And this is what the graph looks like if everything works well. So this is kind of ideal. So you see like an explosion of fitness. You see on the right a representation of the neural network that is controlling these robots in this case. And after, in this case, 190 roughly generations, kind of they are able to balance already for, in this case, 32 seconds. And then, because it's a flexible simulator, we made different scenarios. This one is funny because you see when the robots move randomly, obviously they totally fail at balancing this stick. So the fitness function in this case is defined as the trying not to let the stick be dropped. And then now you have to look very closely. So what they evolved to do is, sorry, that was again the same video. Yep. So I don't know if you got that, but they kind of evolved to exploit the glitch in the simulation. So because it's overly kind of simplified, so they only make this one tiny movement in the beginning to set the pole straight, and then they just don't move anymore. And this is actually the perfect solution in their given environment. So that is kind of interesting case where this has over-adapted to a glitch in the simulation or to a particular property of the simulation that is not very realistic. We did another scenario where robots learned how to stack bricks. As you see in the bottom right corner, like the left one is failing miserably. The right one is kind of already much better at doing it after a couple of generations of evolution. Sorry. Yes. We can also do this in the cloud. So in this case, we have 48 CPU cores running 48 simulator instances parallel on Amazon. This was another example where robots learned to work together to push a brick or a block that otherwise, if they would try to do it alone, they would not be able to do. So you see this guy just hitting it kind of with the lucky punch, but you cannot move it because it's too heavy. And then after the evolution, they evolved a control system that actually makes them kind of, you can see they are kind of drawn to red objects. They kind of tend to create formations like this, and then in this case, the fitness function was defined as the total distance that this red cube has traveled, and the robots to achieve this task only have a very primitive 4-pixel vision sensor. So it's still quite far away from these kind of scenarios, but keep in mind that 20 years ago, like what you see on top was $10 million for the same computational power that now you have. There is no picture yet, I think, with the PlayStation 5, but the PlayStation 5 was supposed to have something like 10 teraflops. So there's like a, this Moore's law that is also questioned, but still it's kind of a very clear tendency that this kind of explodes, and with it, everything that depends on computation and simulation is one such thing. And if you use simulation as the evaluation stage in artificial evolution, then this can be expected also to become more and more powerful. So yeah, thank you very much. I did this workshop together with Soroush Garivani and Matthew Gordon. And I teach at eCAADe in Barcelona, and there's a master's program for robotics in construction called MRAC, so please check it out and write to my email if you have any questions. Thank you.
Cool. Thank you very much, Raimund. Okay, as we are running out of time, I will pass just next to the Alessandro Mentrone with the properties assemblages workshop. And here you go.
Okay.
Yes.
Hi. My workshop was cognitive assemblages, and it was run with Alessio Rioli, and we are both from University of Bologna. And basically, the concept of this workshop revolves around a reinforcement learning algorithm that is trained to assemble discrete elements. So you basically provide discrete elements that are defined both from their geometry and from their connections possibility. And then the algorithm learns how to assemble those elements in order to reach some special qualities that are defined by quantified spatial descriptors. And those special qualities range from density to directionality to structural connectivity to spatial connectivity. And basically, every participant should design its own tiles, its own elements, and define activities. And then you should select which parameter are needed to be trained. So on the left side, you see an untrained model in which everything is done randomly. And on the right-hand side, you see a trained model. And of course, you see emerging some patterns, some more spatial and architectonical quality. And those qualities are both depending on the tile design and the type of training that the agent undergoes. So basically, what happens into this design is that the design agency is not into the designer hand in the tile design, it's not into the agent, the neural network. It's in the precisely in between those two agents. And basically, what happens is that even if the basic files are similar, the history and the choices that are made during the training lead to total different configuration, total different solution. And of course, the training was supervised here on TensorBoard. Everything was run inside Unity 2D, and the training was supervised on TensorBoard, so everyone had a visual feedback of what's going on inside the training. And you can see more clearly that during the training, of course, some qualities of the original aggregation are retained. Some of the qualities gone away because, of course, the algorithm is trying to reach the goal that is set by the designer. But the key concept is that this is not merely an optimization tool, because you are not just implementing some preconceived idea of what the design should resemble. It's more an exploration, because the agent owns its own spatial sensitivity in order to explore and navigate this complex field of possible designs, basically. So you can see that from basic aggregation, you can lead up to complex spatial organization, and everything is done starting with just a few simple elements that, of course, in those simulations are designed by hand, but of course in a more production-ready workflow, they can be, of course, prefabricated architectural elements. And you can see that from just simple tiles, just from simple connectivities, you can see that a really complex spatial organization, really complex both material and spatial hierarchy, it's formed. And as I said before, it's precisely the space between the agent and the designer that is occupied by this algorithm. So summing everything up, if you give up some part of your design agency, of your authorship to this network of cognition between you and this non-human cognition, you can reach new and more interesting spatial qualities and new types of architectures. And we did this work in 2 days, so obviously it was a bit too short the time in order to go deeply inside everything. But I see that a lot of people decided to work more on the design part of the equation. Some other people decided to work more on the machine learning part of the equation. I'm not stating that you should find precisely the point that is in between, in the exact average between those two polarities. It's up to you also deciding if you want to go more with the design task or more with or leaving more freedom, more design agency to the neural network and see what happens next. So thank you to eCAADe to host this workshop. Thank you for every participant. If some of them are here hearing this presentation, and see you soon.
Thank you. Okay, nice workshop also. Next one will be Maria Gividaru with the digital twin workshop. So now you should be able to go.
Thank you so much. And thank you for organizing it. It was great, to be honest. I really enjoyed it. And thank you, the eCAADe, and the participants, of course. Just give me a second, because it's my first time that I'm presenting in WebEx. So many apologies for that. I hope you can see me. The workshop was about an introduction to digital twins, some case studies that we did in Bentley. Of course, sorry, I have to remove this stuff. It was about that I'm Maria, I'm from Greece, I'm a civil engineer, I work in this company, then I joined Cambridge, okay, I did an MPhil, computer science, I joined Bentley. Bentley is not about cars, please, don't, I wouldn't like to hear this again. Bentley is something more, but we're not going to see the video, it's about infrastructure. During my timing there, I worked with many partners such as this, and we did some interesting projects, most of them related to digital twins. Just an introduction about what is digital twin, especially in infrastructure, because it's very usually we see digital twin in other industries. So digital twin is something like the digital replica of a physical model, of a physical infrastructure. So we want a model and something that connects the physical model with the virtual one. So in order to have this, we need especially something. Sorry. We need some things like machine learning, artificial intelligence, and especially Internet of Things, because usually we put sensors on this infrastructure in order to in order to understand their behavior. We talk about digital twin in construction and how we can pass data from the model, the real infrastructure to the virtual model. We talk about some scenarios in this workshop. One of them was about the CDBB. The Center for Digital Build Britain, which is located in the University of Cambridge, and we decided to do the digital twin of West Cambridge. When, for example, here we took some photos of with a drone from the area, inside from the area. Then we did laser scanning of the area. We put all of this together in order to create the model, which is the one we need for digital twin. And then we put some sensors like for humidity or temperature in order to get what is happening inside the building, because this is usually what it changes on a building. And here, for example, you will see that inside some areas like lab areas, we get some information about the measurements of the pumps, as you can see here, and so on. And then we had some questions during the workshop. Do you think that any type of simulation is a digital twin? For example, a flood simulation here in Lisbon. Do you think that this is digital twin? And of course, many of them replied, well, I don't think so, that this simulation is a digital twin, which I think is a correct answer. And then some, again, simulations from a petrochemical plant in the US. As you can see, the level of the river over there rises. So again, this is not a digital twin. Or here, for example, that we have some, where this doesn't play. We have some, by using machine learning, we took again the reality mesh of this model of this building. So we took again photos and we just recognized the cracks automatically of this model. Again, I don't think this is a digital twin. And then this another video with it's project with Highways England. When let me show you the more quicker one. This one. When we took some videos, these videos from the road on the same time, they recognize if this is a barrier, if this is a post, and if it's in a good quality. This was a project around England. This actually is a road around Birmingham. And we, except for recognizing what is this and where is this, like this road marker, this is a barrier, this is a post, we also assessed the road furniture of this area. And this happened simultaneously. So this is almost a digital twin, but it's not inside a model. So again, we had this type of questions during our workshop. Of course, we discussed about the Bentley's goal is going digital, and we want to provide innovative software and services for infrastructure. This is why we really focus on digital twin, because there are many benefits on all the project life cycle. And of course, if anyone is interested, you can join us in this day on the 22nd of September, where speakers from different industry sectors like Volkswagen, the automotive sector, General Electric, Anglo-American, which is the oil sector, Pygmalios, retail sector, they will talk about their interpretation of digital twin and some case studies. So thank you so much.
Thank you.
Thank you.
The next workshop will be about the dynamic canvas. And presenter will be Tugul Yazar.
Yeah, thank you, Martin.
Perfect.
Trying to share my screen now.
Yes.
Okay. Hello, everyone. I'm Tugul Yazar. Together with my colleagues Pelin Dursun Cebi, Nilüfer Kozikoğlu, Oğulcan Üneşi, Büşra Balaban, and Sena Erdem, we have been studying in a scientific project which is partially about the development of a new space syntax tool. The tool is called SpaceChase, and it's about creating and manipulating dynamic graphs which represents spatial configurations. There are several precedent tools such as syntactic, that focus on similar aims and purposes, but the original focus of SpaceChase is the utilization of dynamic graphs into a rather static computations of space syntax. Nowadays, we are experimenting in finding ways to integrate dynamic graphs in real-time motion with the traditional metrics of space syntax, especially in the early design process. So this is the current state of our tool. It is developed in Python language inside Grasshopper and compiled as a new set of components, and it is suitable to be used along with the geometric optimization tools of Kangaroo so that the dynamic outcomes can be achieved. Previously, in the project, we have organized 2 workshops to test the earlier versions of the tool. The eCAADe gave us an opportunity to conduct a 3rd test by using the current version of the tool. So this is as I said, latest version we developed after the feedbacks from the first 2 workshops. So in the 2-day workshop called Dynamic Canvas, 11 participants have attended and tested the tool. After a short seminar on space syntax, network thinking, and graph theory applications, participants were introduced with the tool, and they were asked to use it in a hypothetical, open-ended, or well-defined design conditions. Here are some results or some images from the process that while we have been testing the tool. So the results reveal several bugs as well as new and open potentials for further development. For example, in terms of using the space syntax data inside any other functionality that is presented by Grasshopper environments. And even we had a small update at the end of the first day of the workshop, so it is a quick process, and the tool is developed currently under development by Oğulcan Üneşi. And these images, also you can find them in the gallery section of the eCAADe website. We show some of these tests to you, and we have several videos showing our process and some student works. And today, this tool is capable of creating dynamic graphs and offer a designer as alternative spatial configurations in motion. Since the online workshop had many advantages, such as quick and easy gathering of people and real-time feedbacks, there were also negative effects in terms of the concentration, the difficulty in creating and maintaining the motivation and atmosphere, pedagogical aspects on guiding the participants towards a certain aim, and of course the technical limitations which are time-consuming to be solved from a distance. And at the end of the workshop, we had a discussion together with the participants and got at least few feedbacks and examples from them. The most important outcome for me was to meet the people who are interested in the same topic, whom we would not know otherwise. We hope that we are going to finalize the tool and publish it at online platforms such as Food for Rhino before the new year. Thank you for listening.
Thank you. Next one will be the dynamic factory.
Okay. Do you hear me?
Yes.
Okay, great. So, all right. So my name is Anatoly Kotov, and I'm a research assistant at the Brandenburg University of Technology. I'm also writing here a PhD. And this workshop was called the Dynamic Factory. Our workshop was consisting of two main parts, so the conceptual and the practical part. The first part was the conceptual. During it, we went through the concepts of the controlling of the robots. In our case, we had a lab with the universal robots. We went through the MQTT IoT protocol and the simulation of the complex robotic system. In this case, we can see our architecture of the communication of the robots and the controlling systems. So we were able to actually demonstrate not only the sort of conceptual demonstration or simulated versions, the participants were also able to see how it's implemented in practice, which benefits you can get with this, and also what is not, let's say, so nice as in the advertisements. Also, we were able to demonstrate the connection between the rhino and the grasshopper with the robotic simulations. We were using the robotics and use it to produce the fabrication program for the robots. For instance, this was made by one of our participants, and we have several such digital models prepared for the fabrication. And the second part of our workshop was highly practical. This was the milling of the mold with the dynamic following of the other robot. So the first robot, as you can see, is holding the milling system, which was attached using the custom printed holders. And the second robot, you can see it on the right, was holding the vacuum cleaner. As if you have ever used the CNC machines, you know that it really produces a lot of dust, a lot of material. And so this showcase, although it was completely built specifically for this workshop, in fact, you can, with some modifications, apply this in your practical applications. So the main focus of this workshop was the dynamic following of the second robot. So the first robot, I'm just return. So as you can see here, the robot setup, the first robot was milling the mold. So here you can see actually the first milling pad demonstrated. It's in the process of milling, while the second robot was following the vacuum cleaner. And we also had a real-time monitoring and the controlling of such system. And here you can see the milling process. It's like, for instance, here we have the second stage of trim cutting, so to say, and as the milling result. So currently I would like to demonstrate you a little bit of video because it's much more interesting to see such systems in the motion. And the best thing, I guess, which was really, I would say, which I really enjoyed very much was the participants of this workshop, because they have really a lot of interest and endurance during this workshop. Because as you can see, it was highly practical. And if you go from the simulations to the practical applications, you always had some, let's say, problems of the particular systems because they behave differently. But we went through all of these problems and eventually completed it to the practical application. So here you, for instance, can see the milling process. Like the second robot is following with the little time lag to ensure that we will not collide the second one. And although 2 days was not enough to mill all the models from our participants, I will just mill them all and so to send the results to our participants too. So yeah, I would like to thank again our workshop participants and also the organizers of the eCAADe. Thank you.
Thank you, Anatoly. So the next one will be the KUKA Cloud Robot Control for Remote Robotics workshop. And I give the privilege to Ethan, and here you go. And you're ready to present. Yeah. But you're still muted.
Is that better?
Now you're unmuted. Yeah. Perfect.
Great. Let me just go to presentation mode here. Okay. Thank you, everyone, for your time and attention. My name is Ethan Kerber. I am a researcher at the Chair for Individualized Production at the RWTH Aachen. My interest is in automation and steel fabrication. So oftentimes you see us playing with robots and sparks and having a lot of fun with these two very exciting tools for creativity. I am lucky enough to work with a huge talented team ranging from Professor Sigurd Belchochen and Dr. Sven Stum. I'm sure you're familiar with their work in the Association for Robots in Architecture. I'm sure if we were in person, I would recognize many of you from our conferences in the Robots in Architecture. I'm also a managing editor of the Journal on Construction Robotics, so a little self-promotion. I would love to hear more about your research in a journal article. If you have any interest in publishing some of your work on construction robotics, please check us out online. We have some really interesting articles coming out soon, and I think you'll find them from the talks that we've presented here so far quite exciting. So as you know, the benefit of working with the Association for Robots in Architecture and so many of our academic institutes is that we get to travel the world. And this kind of came to a stop. I was in Dubai, actually, just the night before they closed the borders in Europe, and this was a real shock to me. So as we started to come up with the ideas for how do we continue to teach, we started going digital, and these workshops were no exception. But a lot of our work focuses on digital fabrication, and so we're really interested in, even in these times of social distancing, how do we enable really close collaboration? So we started to come up with a new process for allowing students to remotely access our robots and to control them through the cloud. So in this workshop, we had the second test of what we're calling KUKA CRC, which is KUKA Cloud Remote Control. So we had 4 to 5 participants that were able to learn about how to program a robot. In this case, we're using a KUKA EVA, a force torque sensitive robot. So they learned all about how to use traditional programming tasks like line-to-line movements, point-to-point movements, but also how to use some of the unique features of a force torque sensitive robot, like move until contact. And these are things that are made possible through Dr. Stum's PhD, where he's allowing us to access the torque sensor, the torque values from the robot and take action on them. So what's interesting about this process is that we were able to teach the students, some of who had never really worked with robots before, how to program the robots, how to simulate the robots, how to use evolutionary algorithms to try to figure out where the robots could reach, how they could position their objects in space so that they could get a successful collision-free path, how they could simulate whether these, in this simple example we were using for this 2-day workshop, bricks and just stacking bricks, which is nothing new, but the interesting part was that they were actually the ones to control the robot from the comfort of their own homes. So we also had basically every time the robot drops a brick off, the entire group of people working in this environment had that same brick instantiated in their Rhino model. So we played kind of a reverse game of Jenga on the first day, where one student would put a brick down, and that brick would instantiate in everybody else's Rhino environment, and then they could stack another brick on top of that. So we all would take turns stacking bricks on top of bricks until it, well, it fell over pretty quickly, I got to say, because they were just learning how to do this process. And as we're instantiating the as-built model, we can really quickly compare it to the digital model and see the deviations in our robotic process in real time live. So the students were able to monitor the process through the through somewhat, I'm nervous to call it a digital twin now after listening to Bentley's presentation, but the robot is updated in real time in the Grasshopper environment. So they have two robots, one that can simulate what's going to happen with the robot. Then they have the robot control where they could actually book the robot and send commands to it from their home. And then we're sending them back information about the actual robot, both video streams as well as data streams. So we're sending them the position of the TCP, the joint axis, the torque values, and if the robot is booked or not. So they are actually controlling the robot from their home. They could log onto a website and check out what's going on through webcams. Actually, I have the website up behind me. You can see the robot is had about a 3-second delay. You can see me wave, and then 3 seconds later, that wave. So it's much faster to see what's going on in the digital version on their Grasshopper model than it is on the stream. So we try to provide as much in-person experience while maintaining this, this new situation of social distancing. So this is what the website looks like, where they can look at their process. We have a camera on the robot itself. We have one over the work cell, and then we have another camera that was streaming from the webcam behind me. So all in all, it was an intense 2 days. We had a lot of fun. We taught them a lot of interesting concepts about computational design and robotic fabrication and how to actually execute these commands from the comfort of their own home. And I've taught a lot of classes digitally in the past month since the beginning of the year. And I can say that the students are never quite as engaged as when they're able to control robotic processes themselves. So we're really interested in all the work that's been presented here and how we can start to connect our design ideas to the cloud, to the robots, and keep really close collaboration between our ideas and the creation of what we have in our minds. One student left this really wonderful comment. I've taught a lot of, as I said, digital lectures. She described it as an epic experience. So that's a pretty high praise. I was quite happy with that. And she further went on to say, being able to stream construction data between digital and physical realms from different locations in real time is a game changer. And so we're looking to develop the KUKA CRC into something of a product that, because we do feel like all the architectural schools that have robotics labs are facing the same struggle, where we really want to work again very closely with our students and have them feel material, feel processes, struggle with the challenges, and come up with creative solutions to overcome them. So we hope that this is something that we could share with the world soon. And yeah, we're happy to share it with you here. And we thank the eCAADe organizers for their wonderful support and opportunity to present.
Thank you very much. Awesome. Next and last one, and yeah, the next keynote is pressing. Will be machine learning for urbanity by Swanko. Here you go.
Yeah, okay. Can you hear me?
Yeah.
Cool. So, in this workshop, we discussed how actually you see. Wait, do you see my screen? No.
Not yet.
I forgot.
Yeah, that's perfect.
Yeah. Okay, nice. So, I'm Sonko. I'm a research assistant at BTU in campus in Germany. I work in the same lab with Anatoly. So I was part-time in his workshop sometimes, popping up. But never mind, like our workshop was about how to implement machine learning methods in general urban design, like in general urban design tasks. So like we just, on the first day, we just took, the point was just to take a bounding box from OpenStreetMap or any map data service and just like extract it. That could be like your neighborhood, your place, in any place in the world, literally, and like just get that bounding box and extract all the relevant information from it. And in this case, we took the most frequent and most busy streets in it, and just like calculated all these routes, calculated what is the most frequent route, what is the most important path in this whole entire area. And after that, we started like to generate the new model out of it. Like using those streets, we're gonna generate a whole entire model, like reimagine this whole piece. How would an algorithm perceive it? How would an algorithm make it ideal in its own way? By using a lot of these kind of parameters for centrality and betweenness, and what is this, like all these kind of urban laws and regulations, right? And to regenerate a new image of that piece, let's call it. So you can see the paths. This is actually Cottbus. You can see the paths here, which are the most busy paths in this piece, let's call it. And then you see the newly regenerated proposition of parcels, and you can see the street axes here, how the algorithm would actually reimagine this piece. And after that, we took it like a step further to like running neural network and like and some regressions and stuff, like algorithms to actually generate the buildings themselves. So like to propose the building heights and to get all of this relevant cityscape data, like to make this kind of a proper cityscape, like with all the correct heights and stuff. Like, so we have kind of this propositional neighborhood, let's call it, or predicted how would this kind of cityscape in this piece would look in an algorithm size, when it should be quite pretty much ideal, pretty much. And that was for the, and yeah, and these are also some images. Also, like we added these kind of green spaces, like all these parcels and stuff that were like really unfeasible. You know, like they were illogical. Like there was a kind of setback, like a parameter that would classify which would be like a public space or not, or just a park, which is not so, which is fit for a building parcel, which is not. And yeah, and this is from some of the students. This guy was from Brazil, I think, so probably somewhere there. And this one is from Copenhagen, like. And also we generated also the prices, like according to the price of the location, like the actual the real-time price of this city, let's call it, like also accumulate all of these kind of plot generation and building height, and like the general building generation also according to this kind of real-time data, which you like just say the average price of in this area is that much, and like it can like generate this whole prediction based on all of these real-time parameters. That was for the first day. On the second day, I think I have the building generator here as a video. Yeah. Is it going? Now let's go. So this would be the building generator actually. So that was for the first day, but on the second day we put our existing models, like all of these generated predicted models, like into a reinforcement learning setup. Like we just let an agent in and let him choose which is the best parcel, let's call it, for some reason. Like imagine like in this new neighborhood, like you meet a developer or somebody who's interested to develop something around it, and he wants to choose the best parcel according to some reasons, some parameters. So we just put an agent in and let him like choose a parcel, like make him like find his way and choose the best thing according to some parameters. And I have a video of that. It looks like this. And yeah, and there is another on a much broader scale where there's actually a point, a place mark, like maybe it's a park or a hospital or some place of interest that he's searching for stuff around it within a radius around that one. As in the other case, it was on the entire generated part, let's call it. So that would be pretty much it. So especially the students, I would say, had fun. Like it was a bit intense because there was a lot of complex topics to be grasped in just 2 days, but at the end there was quite nice discussions and like stuff. Even though, especially for the reinforcement learning, like it wasn't working for most of them because it requires some technical knowledge and setup. But overall, it was really a nice experience. So thank you everybody for organizing this and letting me do this workshop. And hope to see you soon.
Yeah, thank you. So cool. And thank you all presenters and workshop leaders or supporters, and also you which participated in these workshops. Was awesome material and like an image overflow. I hope that we doesn't rush too fast through it, but unfortunately we don't have any time left. So from my side, thanks for sharing all your experiences and outcomes, and also the pros and cons you recognized during your workshops. And it's interesting that these workshops, which are really hands-on and yeah, practically, of course, also work during these Corona or COVID-19 pandemic times. And as you also mentioned, it's super difficult to get the people motivated and so on. And yeah, but the outcomes look like it's possible. And yeah, I think we should go on with it. So thank you all, and let me see how we do with the recording of this session here. Yeah, I will ask the other organizers, and yeah, see you for the next session or inside the bar. There are cool events taking place in the bar, like a live session. And yeah, the next keynote is I think in 3 minutes or 5 minutes. Let's see. Yeah, thanks and see you.
Thank you. Bye bye.
Thank you, everyone.
Thank you.
Ciao, Martin. Thank you.
Thank you very much.